Okay, so we are going to talk about 5.4, which our goal will be to perform operations with imaginary and complex numbers. So an imaginary number is going to contain I. It's just going to be one term. It'll contain I. So for example, you could have 6i, or negative 2i, or I square roots of 3. Any of those would be examples of, there we go, an example of an imaginary number. A complex number is going to be two terms, and it's going to have a real part and an imaginary part. So this is a number written as a plus bi, where the imaginary number is just the bi part. There's no real part, so this is a plus bi. A and b are going to be real numbers. Okay, they don't have to be counting numbers, they don't have to be integers, but they are real numbers. So a couple examples here could be like 3 plus 7i. Or another example could be 1/2 plus or minus the square root of 7 over 2i. So this is still an imaginary number. That's a real number. 1/2 would be your A. Your B value would be the square root of 7 over 2, which is irrational, but it's still a real number. If you type it into your calculator, it's still going to give you a decimal value. Okay? So we consider the A part is the real part, and the B is the imaginary part. So what are these numbers then? Where do they come from? Well, an imaginary number, it comes from the square root of a negative number. So, for example, all of this comes from the square root of negative 1 is equal to I. Okay, if you type in the square root of negative 1 on your calculator, square root of negative 1 on your calculator, it's going to tell you error. Oops. The square root of negative 1, enter. It says non-real answer, because that is I. The answer is actually I. That means that if we were to square I, so if you square both sides, what do you end up with? What would I squared be? The value of that would be negative 1, because if you square this side, you get I squared. If you square this side, it just undoes the square root sign. These are two of the things that you will have to know for your quiz. It's very important that you know both of those things, because without knowing those, you won't be able to simplify radicals that deal with imaginary numbers. So we do have two review problems. The square root of 28. Now, if you just did that review assignment, this should be fresh in your mind. You would break this apart into a perfect square and a non-perfect square. So it'd be like the square root of 4 times the square root of 7. Well, the square root of 4 is 2, so this becomes 2 times the square root of 7, which is 2 square roots of 7. We don't have to write it with that multiplication sign in there. Okay. Here, this breaks up into the perfect square. Would be 9 and 2. 9 times 2 is 18. Square root of 9 is 3. That's why we picked it. 3 square roots of 2. So 2 square roots of 7 for this one, 3 square roots of 2 for that one. If you did not do that review assignment, I highly suggest you watch those short videos, because this is going to make so much more sense once you do that review assignment. So, some new examples. Notice these all have a negative value in them. So the very first thing that you're going to always do is pull the negative out. So we're going to write this as the square root of negative 1 times the square root of 144. Negative 1 times 144 would give you negative 144. The reason I did this, because I know the value of the square root of negative 1. It's I. But I can also take the square root of 144, which is 12. Now, I wouldn't write something x12, and that's why I'm not going to write it I12. I'm going to write it 12i. That would be your final answer for this problem. This next one, same idea. Take out the negative 1. Negative 1 times 36, both under radicals, the square root sign. Square root of negative 1 is I, so we have I times the square root of 36. But the square root of 36 is 6, so here I have 6I. All right, the square root of negative 18. Now, 18 is not a perfect square. These ones worked out because 144 and 36 were both perfect squares. In the future, I could see that you could probably answer these questions without showing all of those steps. You'd be able to look at that and tell me the answer is 12I. Look at this, tell me the answer is 6I. Here, though, you can't do that because 18, you can't take the square root of it. So what you're going to need to do is, again, take out the negative 1, but you're also going to want to break down that 18. I'll leave it alone in that first step. The square root of negative 1, this is going to break down into 9 times 2. And then what we're going to get is I times 3 times the square root of 2. The square root of 9 is 3. The square root of negative 1 is I. The square root of 2, you can't do anything to it. So our final answer here, you're just going to rearrange it a little bit. If I were talking about these first two, I wouldn't write x3, I would write 3x. So I'm not going to write I3, I'm going to write 3I. Square root of 2 will be last. All right, so this is the last one. You're going to start by pulling out the negative 1 times the square root of 72. Okay, so we have 72 will break down into the square root of 36 times the square root of 2. Don't forget about that square root of negative 1, but we can write it as an I instead at this point. This is going to become a 6, so we have I times 6 times the square root of 2. A lot of people try to only write this here and leave this up here and forget about it. The problem with that is if you don't write it all the way down, there are parts up here that get missed. So I would recommend making sure you're writing this so that it's always equivalent to the very first one. Negative 1 times 72, or I times the square root of 36 times the square root of 2, which is also 72. I times 6 times the square root of 2. You haven't changed the value of this. So 6I times the square root of 2. So it's very important that with each of these steps, they're all equivalent to the very first one. If you forget parts, then they're usually forgotten in the final answer, which we don't want. All right, so the last thing here is going to be taking I to powers. So we have I to the first power, which, actually real quick, before we even get onto this, let's do a little bit of review. If you take I squared times I to the third, that's the same thing as taking I to what power? And if you want to, you can write it out by expanding it. Xx times xxx. And so this is the same thing as taking x to the fifth power. So what you're doing is you're adding the exponents together. 2 plus 3 is 5. Okay? If you were to take and say x squared raised to the third power, what you have is x squared times itself 3 times. In this case, we have, using that same rule from before, x to the power of 6, which from the original, you could do 2 times 3 and get that 6. Okay? That's important review information of how to deal with exponents because that's how we're going to take I to powers. I to the first power is just I. That's it. I. I squared, we already discussed what I squared was up here. I squared is the value negative 1. If I have I to the 8th power, what I want to do is split this up into powers that I know, like I squared. So what I can write this as is I squared raised to the 4th power, because I squared raised to the 4th is I to the 8th. But this allows me to say, okay, well, I squared is negative 1. If I raise negative 1 to the 4th power, Now I can put that in my calculator, or I can know it. If I multiply negative 1 by itself an even number of times, negative 1, oops, I need to put it in parentheses, negative 1 raised to the 4th power is equal to 1. So my final answer there is 1. If I raise it to the 15th power, this is the same thing as raising I to the 14th times I to the 1st. Now, the reason I did that was because I can write I to the 14th as I squared raised to the 7th power, because I know I squared is negative 1. Negative 1 raised to the 7th power, that's an odd number of times, so it should be negative. Let me show you. Negative 1 raised to the 7th power is negative 1. So I have negative 1 times I. Well, negative 1 times I is negative I. And that would be your final answer. There are 4 possibilities when you're raising I to a power. Your answers could be positive or negative I, or positive or negative 1. If you want to write it out like I, negative I, 1, negative 1, you can have those 4 possibilities. Okay, the next thing that we're going to do is multiplying with imaginary numbers. Now, this is what I was saying when I was doing the multiplying radicals review. You can't multiply negative 18 and negative 144 together because the negatives will then disappear. What really you have here is we already simplified the negative square root of 18 on the first page. So what you're going to do is you're just going to simplify those individually. So when we simplified the square root of negative 18, we got 6i square roots of 2. Oh, nope, sorry, 3i square roots of 2. Times, so that's what we got for the square root of negative 18. When we simplified the square root of negative 144, we got 12i. So what we're going to do is now that we've simplified both of those individually, now we can actually multiply those together. Now anything that's outside the radicals, like 3i and 12i, we're going to multiply those together to get 36i squared. Anything that was under the radical is going to remain under the radical, so the square root of 2. Now, we can simplify I to a power, so in your answers, you'll never have I to a power. You'll always have either I or no I, but you can't have I squared. You know the value of I squared. It's negative 1. And so what we get here is negative 36 square roots of 2, and that's your final answer. So you're taking the ideas from before, so simplify that, simplify this, and then multiply what's on the outside, keep what's on the inside, and simplify from there. All right, this next one, negative 5i times 3i. Think about this as if I had negative 5x times 3x. I know that that would be negative 15x squared. Same idea here. We get negative 15i squared. Now again, you can't have I to a power when you're simplifying because you can simplify I to powers. So I squared is negative 1. So we have negative 15 times negative 1 here, which is positive 15 for our answer. If we are given something like this, and let's say we're asked to find the x-intercept, and we plugged in 0. And when we were solving, we got negative 64 equals x squared. And the problem is you go to square root both sides, and you were stuck with taking the square root of a negative number. Now, before I told you that it was acceptable to say no x-intercepts. Now, I will give you an equation like this and ask for you to solve it. You will have to continue from this point on. Now, if you are solving and you take a square root, you have to think of a positive or negative version of that square root. So now that we have x is equal to positive or negative, the square root of 64, or square root of negative 64, what you have to do is you're going to have to simplify the square root of negative 64. So the first thing we're going to do is we're going to pull out that negative as an I. Now the square root of 64 is 8. So we actually have positive or negative 8i equal to x. And we actually solved this equation. I do want to show you one more because sometimes they get a little bit trickier than just that one. So if I gave you 0 equals 9x squared plus 72. We also have to solve this one. So subtract 72 on both sides. Divide by 9 on both sides. Square root both sides. Now at this point, when you take the square root of both sides, that's when you have positive or negative, the square root of negative 8. Now, if you want to, you can do this on like scrap paper or off to the side. Not really scrap paper, but off to the side, you can simplify the square root of negative 8 or keep going right here. I say scrap paper, like put it over here, because sometimes this is pretty lengthy of what we're solving. You'll see when we get into our next section during the second part of Unit 5. So for right now, though, I'm going to pull out the negative as I. I'm going to break down that 8 into 4 and 2 because 4 is a perfect square. Now this will become 2i square roots of 2. So x will equal, I'll rewrite it, x equals positive or negative 2i square roots of 2. And that would be your final answer. All right, so now if we have some weird looking thing equal to a complex number, the way that we're going to do this part is this 7 is the real part of our equation. On the right side, that is. On the left side, anything that's not being multiplied by I is the real part. So we're going to set it up like this. 3x minus 5 equals 7. Then, okay, so then very similarly, anything that's being multiplied by I is this imaginary part. And anything that's multiplied by I. So we have y minus 3 equals 6. So now we have two equations, and all we're going to do is figure out what x is and figure out what y is. So for the x part, we're going to, now this is just basic what you guys learned back in 7th and 8th grade on how to solve for these variables. So 3x equals 12, x equals 4. Over on this side, you're going to add 3 to both sides. You're going to get y equal to 9. And that's all you're going to do. So we'll try this next one. The real part on the right side is negative 8. So the real part, all the parts that are not being multiplied by I are 2x plus 4. And so we're going to set them equal to each other. Now, the imaginary part has to be equal to 2. And this imaginary part is negative of what's in these parentheses. So when I go to apply this, it is negative of 3y plus 7 has to equal 2. So you can do this a couple different ways. When you go to solve this, you can either divide by negative 1 on both sides to get rid of the negative, or distribute it. I usually like to distribute it, so that's what I'll do. Add 7. Y is negative 3. Over here, subtract 4. Divide by 2. X will be negative 6. All right. On to the last page of the notes. Oh, not the last page, the second page. Second full page. Third page of the notes. Add or subtracting complex numbers is no different than all you need to do is combine like terms. If you're adding, all the parentheses just drop. 2 minus 7i plus 3 minus 4i. So, combine like terms. 2 and 3 are like terms. You get 5. Negative 7 and negative 4 is negative 11i. And you're done. Over here, though, when you're subtracting, the first one you can drop the parentheses. On the second one, though, you're going to have to distribute that negative sign. So minus 2 minus 4i. Now again, you're combining like terms. So the 5 and the negative 2 are like terms. The negative 7i and negative 4i are like terms. So you should get 3 minus 11i. That will be your final answer. Multiplying complex numbers is no different than if I were to give you something like x plus 2 times x minus 3. What we would do is we would FOIL, and we would get x squared minus 3x plus 2x minus 6. Combine like terms, and you'd get x squared minus x minus 6. So we FOIL. That's how you would do that. Now, it's no different than if I were dealing with x. Now, the variable in there appears to be I. And if you had something like I squared, we couldn't leave it like that because we know how to take I to powers. So the first thing we're going to do is FOIL here. First times the first, 2 times 9, is 18. Your outside is 2 times negative 3i, is minus 6i. The inside is 4i times 9, which is plus 36i. And last is 4i times negative 3i is minus 12i squared. Now the first thing you're going to do is combine like terms. So these I terms are like terms. So we have 18 plus 30i. Negative 6i and 30i is, negative 6i, 36i makes 30i. Minus 12i squared. Now I squared, though, has a value. I squared is negative 1. So we actually have 18 plus 30i minus 12 times negative 1. So that's actually going to turn into 18 plus 30i plus 12. And now, once you've taken care of that I squared, you'll notice that we again have more like terms. 18 and 12 are like terms. So we have 30 plus 30i. And that would be our final answer. We're going to try it here on this one. First times the first, 2 times 2 is 4. Outside will be minus 8i. The inside will be plus 8i. And last will be minus 16i squared. Negative 8i and positive 8i, combining those like terms, turn into 0. So I have 4 minus 16, but the I squared, remember, is actually negative 1. So I have 4 plus 16, which is 20. So I'm going to get 20 for that answer. Now, when you have two complex numbers, that sign is opposite. So I have 2 plus 4i and 2 minus 4i. The sign in the middle of our imaginary and our real part is opposites. So because of that, that's what we call a complex conjugate. Now, the purpose of a complex conjugate is when you multiply them, your answer is going to... So, what is a complex conjugate? The definition of complex conjugates, there are two complex numbers. Here we have two complex numbers whose product, so multiply them. Here we did that. The product is a real number. So the answer to when you multiply them has to be a real number. You're going to definitely want to know that. You're also going to want to know is how to find complex. So I wrote out a couple problems here. How to find the complex conjugate. If you are given 3 plus 6i, that's complex conjugate would be 3 minus 6i. Notice your complex part is opposite. Now this one is just an imaginary number because it doesn't have a real part to it. So when we find the complex conjugate, it's just going to be negative 3i. The complex conjugate of 2 minus 3i would be 2 plus 3i. And for this negative 7i, it would just be 7i. Now, for negative 4 plus 7i, you'd have negative 4 minus 7i. And for 256i, you would have negative 256i. All right, so the last step is dividing complex numbers. The first thing that I would recommend for you to do is actually write them as a fraction. So this first one, the way that you're going to write it is 2i over 3 plus 6i. Now, you're not allowed to have I in the denominator. You're not allowed to have I in the denominator. Just like you can't have a radical in the denominator. So what you're going to have to do is you're going to have to multiply by the undercover 1. And the undercover 1 is going to be your complex conjugate over the complex conjugate. So, when we multiply by this undercover 1, you're going to look at your denominator and you're going to say, what's that complex conjugate? It'd be 3 minus 6i. So you're going to have to do that on both the top and the bottom. Now, we're using the same things that we did before. On the top, what you're going to do is you're multiplying 2i times that 3 minus 6i. So you have to distribute. And so what you're going to get when you distribute is 6i minus 12i squared. On the bottom, what you're going to get is 9 minus 18i plus 18i minus 36i squared. And now what we're going to have to do is, so on the top where you see that I squared, you're going to make that negative 1. Because remember, I squared equals negative 1. So what we have on the top is 6i minus 12 times negative 1. We'll turn it into positive 12. And I'll write that in right up here, because that's the same thing as writing negative 1 there. On the bottom, your negative 18i and positive 18i are going to cancel out. And then that I squared, remember, is a negative 1. So you have 9 plus 36 on the bottom. Now, 9 plus 36, you can go ahead and do that. So on the top, you're going to still have 6i plus 12. And on the bottom, you're going to have 45. Now, that is not in a plus bi form, so we have to put it in a plus bi form. So, this is 6 over 45i plus 12 over 45. It's still not in a plus bi form because it's in the wrong order. Also, we'll need to reduce these fractions. You can easily reduce the fractions right on your calculator. 6 divided by 45, hit math, fraction, that's 2/15. So we have 2/15 I plus 12 over 45 is going to reduce to 4/15. So my last step is to write it in a plus bi. So this term has to come second. So I'm going to write 4 over 15 plus 2 over 15i. And that would be your final answer. All right, so this last one that we're going to do, dividing complex numbers, you're just going to write it first as a fraction. You can't have that I in the denominator, so you have to multiply by that undercover 1, which is that complex conjugate. So in the bottom, our complex conjugate is 2 plus 3i. So we're going to do that. That means we're going to have to FOIL the top and FOIL the bottom. So some people like to do this separately, like over here, put some scrap paper. You'll see it in the key how I did it. I'm going to keep it in the entire fraction. So FOILing on the top, I'm going to have 12i. Outside is 18i squared. The inside will be minus 8, and the last will be minus 12i. All right, on the bottom, first is 2 times 2, which is 4. My outside will be 2 times 3i, which is plus 6i. My inside will be negative 3i times 2 is minus 6i. And my last is negative 3i times a positive 3i, which is minus 9i squared. Anywhere where I see an I squared, I'm going to make it negative 1. So I'm just going to write those in red pen here. That is going to become a negative 1. That's going to become a negative 1. And so then what I'm going to also do is I notice on the top I have a 12i minus 12i. And those are like terms that'll go away. On the bottom I have a 6i and a negative 6i, and those will go away. So I'm going to write this a little bit more simplified. I'm going to have negative 18 minus 8 over 4 plus 9. Well, I still have a little bit more simplifying to do. Negative 18 minus 8 is going to be negative 26 on the top, and on the bottom, I'm going to have 13. Well, negative 26 over 13 is just negative 2. And I'm done. That's it for that one. So, that is it for notes. If you have any questions, let me know.